Okay, we're going to be learning today about empirical and molecular formulas. So basically what we're going to be talking about is how do we know the formulas of these chemical compounds, right? So we say that carbon dioxide is CO2, but how do we know that, okay? And basically the answer is the lab, okay? If we do experiments and we get some data, we can figure out formulas of chemical compounds. So this is going to show you how to do that, okay? And basically the way to do this is through both what's called empirical and molecular formulas. So let's get into what they are. An empirical formula is basically the lowest whole number ratio of atoms in a formula. Okay, so it's almost like a fraction that's reduced. So, for example, 1/2 is like an empirical formula. You can't reduce that down anymore. Okay. Um, the thing is, though, the empirical formula might not be the actual formula of the compound. Okay, and we'll get into see why that might be in a little bit. Whereas a molecular formula is the actual ratio of atoms in a compound. It can be reduced down. It might be something more like 3/6 or 4/8, right? And we also sometimes just refer to this as the formula. Okay, the molecular formula is the formula that we've been given so far this year. It's the formulas that you guys have been figuring out, okay? So let me just kind of show you how this works. So let's take glucose over here. Glucose, aka sugar, very important molecule. And so your body uses this and all kinds of stuff. C6H12O6 is the molecular compound, okay? Notice that this is not in its simplest terms, right? How could we simplify this? What do they all have in common? Well, we could divide each one of these by 6, okay? And that would be its empirical. So here'd be the empirical. If we divide them all by 6, we get one of these, two of these, and one of these. So CH2O, okay? That's the empirical formula, okay, of glucose. Okay, so notice how this is fully reduced, but here is like the actual formula. Let's take another example here with carbon dioxide. CO2 is the molecular. And let's see, how can we reduce this down? Can we divide this by anything? No. And that's right. CO2 is also the empirical. So like, what? So sometimes it can be both? Yes. For ionic compounds, almost always your empirical is your molecular. For molecular compounds, sometimes the empiricals and moleculars are the same and sometimes they're different. Just like here, these are both molecular compounds. Here's CO2, they're the same, and with glucose, they're not. So it could go either way with a molecular compound, okay? Okay, so let's get down to it then. What I would do if I were you right now is I would pause the video, copy down these steps in order, so then we're going through the examples. You've already got them set for yourself. All right, I'm assuming you've copied those down now, so I'm going to keep going. So here's an example of a problem you might get. A compound is decomposed to have 32.8 grams chromium and 67.2 grams chlorine. Determine the empirical formula. So step 1, I get my masses from the problem. Boom, given to me already. That's easy. Step number 2, I am going to convert this to moles, okay? And so I've shown you the work down here. I'm going to be taking what I was given in my problem and dividing by the molar mass, aka the mass on the periodic table, okay? So I do 32.8 divided by 52 to get me 0.63 moles of chromium and 67.2 divided by 34.5 to get me 1.9 moles of chlorine. Awesome. Okay, step 3, I'm going to take my mole numbers and divide them both by the smallest. So 0.63 divided by 0.63 is 1, and 1.9 gets divided by 0.63 because that's smaller. And so we get 3.02. All right, so are these whole numbers? Yes. Or they're very, very close to whole numbers, right? Like we would round 3.02 to 3. Okay, so we have 1 and 3. Okay, so now I know that for every 1... this 1 goes with my Cr up here, this 1 goes to my chromium, and this 3 goes to my chlorine. So every 1 chromium, I have 3 chlorines. And so that is my formula, 1 chromium and 3 chlorines. Cr, like there's a little invisible 1 there, Cl3. Okay, here's another example, this time with percents. Okay, we have 68.4% chromium and 31.6% oxygen. So step 1 is to get our grams, but if the problem gives you percents, you just take your percents and change them into grams. Easy peasy. So that becomes 68.4 grams and 31.6 grams oxygen. Step number 2 now, we're going to convert our grams to moles. We're going to do that by dividing the molar mass, okay, just like we've done before with our previous mole calculations. So here's my 68.4. Here's my mass off the periodic table. Divide them up. That gives me 1.32 moles of chromium. Here's my oxygen grams divided by the 16 grams from my periodic table, and that gives me 1.98 moles of oxygen. Which number is smaller? Well, 1.32 is smaller, so for my step 3, I'm going to divide both of them by 1.32, okay? So this means I'm going to get 1 here, and when I do this, I end up getting 1.5. Ooh, not whole numbers. So I got to figure out what I would multiply them both by to make them whole numbers. And hopefully you can figure out here that we would need to multiply this by 2, which means we have to multiply everything by 2, okay? So 1 times 2 is 2, and 1.5 times 2 is 3. Aha, so there we go. For every 2 chromium, we're going to have 3 oxygen. And so that's what we put in there, chromium 2, oxygen 3, okay? So that's empirical formulas, not too bad, hopefully. But now let's talk about those molecular formulas, the other part. How do we figure out those? Remember, empirical is the most reduced form, and molecular is going to be the actual formula, okay? So we're going to use our empirical formula to get the molecular formula. So it's helpful. We have to do it anyway. So now you already know how to do that. So that's kind of step 1, is to get our empirical. Here are the rest of your steps. Again, I would highly suggest that you copy these down, pause the video while you're copying them down, so you've got all the steps, so when I'm flying through the examples, it makes sense to you. Hopefully you've got them copied down now, and so here we go with our example. The empirical formula is CH2O, and the sample has a molar mass of 180 grams per mole. Determine the molecular formula. Now, this could have been a 2-parter problem where you had to figure this out first, but as to not just do it again and again and again, I just gave it to you. So step 1 is easy. We already have the empirical formula. Okay, step 2 now. We're going to calculate the molar mass. So if it's CH2O, we're going to do C plus 2 H's plus an O. Again, these masses are off our periodic table. If you need help with this, go back and rewatch the molar mass lecture. And so once we do that multiplication and add them all up, we get about 30.03 grams. Step 3 is we're going to divide the molar mass given to us in the problem by the molar mass that we just calculated of our empirical. So 180 divided by 30.03 is 5.99. And of course, 5.99 rounds to 6. And so that means we multiply our empirical formula by 6. And so that means our molecular formula would be then C6H12O6. You might recognize that that's glucose, which was one of our earlier examples. So that's empirical and molecular formulas. Hopefully you understand the difference and you see how we can use one to find the other.